The McDonnell Douglas F-4 Phantom II is one of the most significant combat aircraft ever built. It is a supersonic, twin-engine, two-seat military jet developed during the height of the Cold War, when air power was central to global deterrence and survival. The Phantom was created to meet an urgent requirement from the United States Navy, an all-weather, long-range fleet defense interceptor capable of destroying high-altitude, high-speed bomber threats before they could reach carrier groups. These threats were primarily Soviet long-range bombers armed with nuclear weapons. What began as a naval interceptor evolved into one of the most versatile fighter aircraft of the 20th century. The F-4 Phantom II matters because it permanently changed how air forces thought about speed, sensors, missiles, and multirole combat. It marked the transition from gun-centric dogfighting to radar-guided, beyond visual range air warfare, a foundation of modern combat aviation. 2. Origin and development history. The F-4 Phantom II originated in the United States. It was designed and manufactured by McDonnell Aircraft, which later became McDonnell Douglas. The program began in 1953 under a U.S. Navy requirement for a new carrier-based interceptor. The aircraft made its first flight on the 27th of May 1958. The Phantom was developed to replace earlier naval fighters such as the F-3H Demon and to counter emerging supersonic bomber threats. Its performance exceeded expectations, leading the U.S. Air Force and U.S. Marine Corps to adopt it as well. The F-4 competed against contemporary aircraft such as the F-106 Delta Dart, MiG-21, and later the Mirage 3, but distinguished itself through payload, range, and adaptability rather than agility alone. 3. Design philosophy and airframe. The design philosophy of the F-4 Phantom II prioritized speed, power, payload, and sensor capability over lightweight maneuverability. The airframe is a large, structurally robust design constructed primarily from aluminum alloys, with steel and titanium used in high-temperature and high-stress areas. No composite materials or stealth coatings were used, reflecting the technology of the era. Aerodynamically, the Phantom features swept wings and hedral tailplanes, and variable geometry engine intakes to maintain airflow at supersonic speeds. Its wide fuselage accommodates to engines, a large radar, and a two-crew cockpit. Visually and technically, the Phantom stands apart due to its size, twin-engine configuration, and distinctive exhaust plume, symbols of raw Cold War power rather than subtlety. 4. Engine and propulsion system. The F-4 Phantom II is powered by two General Electric J79 turbojet engines. Common variants include J79GE8 early models, J79GE17 later models. Each engine produces approximately 11,800 12,000-pound 52 to 53 kilonewtons, drive thrust 17,900 pound 76 to 80 kilonewtons with afterburner, depending on variant. The twin-engine configuration provides exceptional acceleration and redundancy. The Phantom's high thrust-to-weight ratio enables rapid climbs and sustained supersonic flight, though turbojet engines generate high fuel consumption and thermal stress. 5. Speed and flight performance. The F-4 Phantom II is a true Mach 2 class aircraft. Maximum speed. Mach 2.2 at altitude approximately 2,350 kilometers per hour or 1,460 miles per hour cruise speed. Approximately Mach 0.85 to 0.9 service ceiling. About 60,000 feet, 18,300 meters. Rate of climb, approximately 41,000 feet per minute. Maneuverability varies by variant. Early models lacked leading-edge slats and suffered in sustained turning combat. Later versions, such as the F-4E, improved low-speed handling, but still emphasized energy management over tight dogfighting. 6. Range, endurance, and fuel range was one of the Phantom's greatest strengths. Internal fuel capacity, approximately 7,000 kilograms, 15,400 pounds combat radius, roughly 650 to 700 kilometers, 400 to 435 miles, mission dependent. Ferry range, over 2,600 kilometers, 1,600 miles with external tanks. The aircraft routinely carried external fuel tanks and was fully compatible with aerial refueling, significantly extending mission endurance for strike and patrol operations. 7. Fuel consumption and operating costs. The Phantom's performance came with high operating demands. The J-79 turbojets consume large quantities of fuel, particularly in afterburner. Publicly available estimates indicate fuel burn, measured in several thousand kilograms per flight hour, highly dependent on mission profile and power setting. There is no single standardized cost per flight hour figure across operators and decades, but the F-4 was consistently considered expensive to operate due to fuel consumption, maintenance-intensive engines, and complex avionics. Carrier operations further increased logistical and structural wear. 8. Avionics and sensor systems. Avionics varied significantly by variant and operator. The Phantom employed mechanically scanned pulse Doppler radars, including an APQ-72 and APQ-100 and APQ-120. These systems enabled all-weather interception and beyond visual range engagements, but lacked modern sensor fusion. Electronic warfare systems included radar warning receivers, ECM pods, and countermeasure dispensers. The two-crew cockpit, consisting of a pilot and radar intercept officer, significantly reduced workload and improved situational awareness during complex missions. 9. Weapons and payload. The F-4 Phantom II was originally designed without an internal gun, reflecting missile-centric doctrine. Primary air-to-air weapons included AIM-7 Sparrow, AIM-9 Sidewinder. Later variants, notably the F-4E, incorporated an internal M61A1 Vulcan 20mm cannon. For air-to-ground missions, the Phantom carried unguided bombs, guided munitions, rockets, and specialized weapons. Maximum external payload, approximately 8,400 kilograms, 18,500 pounds. 10. Stealth and survivability. The F-4 Phantom II has no stealth features. Its large airframe, engine inlets, and external stores produce a substantial radar cross-section. Survivability relies on speed, altitude, electronic countermeasures, and tactical employment rather than signature reduction. Defensive systems include chaff, flares, ECM pods, and radar warning receivers. By modern standards, survivability is limited in contested airspace. 11. Real-world service and combat use. The Phantom saw extensive real-world combat service. Operators included the United States, United Kingdom, Germany, Japan, Israel, Iran, and others. Combat deployments occurred during the Vietnam War, Arab-Israeli conflicts, the Iran-Iraq War, limited roles in the Gulf War. Pilots consistently cited its power, durability, and versatility, while noting high workload and demanding flight characteristics. 12. Cost, production, and global impact. Total aircraft produced, approximately 5,195. Flyaway cost 1960s, rough. Lie to United States dollars to $2.5 million per unit. The Phantom became one of the most widely exported Western fighters, shaping allied air forces and influencing future multirole aircraft development worldwide. 13. Strengths and weaknesses. Strengths: exceptional speed and climb, heavy payload and range. Multirole adaptability, structural durability. Weaknesses: high fuel consumption, limited close and maneuverability, large radar signature, maintenance complexity. No fighter aircraft is without compromise, and the Phantom reflects the priorities of its era. 14. Final verdict. The F-4 Phantom II represents a defining moment in aviation history. It bridged generations of air combat, introduced missile-centric warfare at scale, and proved that a single airframe could dominate multiple roles. Though no longer suited for modern contested airspace, its legacy endures. The Phantom remains respected worldwide not for stealth or finesse, but for its unmatched impact on global air power during the Cold War and beyond.